Okay, great news. The video for day 27 is just one screen of two examples, so this should be pretty quick. Example number one is reviewing some trig. Your goal is to figure out what the antiderivative from pi over 4 to pi over 2 for 2 minus cosecant squared dx, and I will give you a little bit of a hint. You should know all of your trig derivatives. If you remember that the derivative of tangent is secant squared x, not theta, then that might help you find the antiderivative of cosecant squared x. So pause the video and see if you can do the next couple steps for this first example. So if the derivative of tangent is secant squared, then the derivative of cotangent is negative cosecant squared. And since we see negative cosecant squared, the antiderivative of that would be negative cotangent. The negative and the negative from the original problem and for the antiderivative of cosecant squared cancel out, and we're left with that statement there. So now you need to remember a little bit of your unit circle. Cotangent is x over y. Pi over 2 is 90 degrees. Pi over 4 is 45 degrees. So evaluate those. And you wind up with the final answer of pi over 2 minus 1. So for the second example, you need to sketch your own region. So find the area of the region bounded by that function, x equals 0, x equals 8, and y equals 0. So the first step in this one is to make a fairly decent sketch of that function with these boundaries. Go ahead and try and sketch that out. Pause the video, try and create your sketch. Okay, hopefully you got something that looks like that. It's just a cube root function moved up 1. With boundaries of 0 and 8 plugged into that function, you get nice neat outputs of 1 and 3. And so now we need the area under that curve, which is evaluating this antiderivative. Again, pause the video and get your final answer before I reveal the solution. Antiderivatives, x. 3/4 x to the 4/3. Remember, you add 1 and reciprocate. So 1/3 plus 3/3 is 4/3. Reciprocating becomes 3/4, and you can check it by taking the derivative of this. 3/4 times 4/3 becomes a 1 out front. 4/3 reduced by 1 is 1/3. So that checks out. Remember that the denominator is the root. The cube root of 8 is 2. 2 to the 4th is 16. 0 to any power is still 0. And then you get a nice neat area of 20. So despite the fact that this is kind of a messy function, a cube root function moved up 1, the area underneath that curve between 0 and 8 is a perfect 20. Okay, most of day 27 is just you practicing your skills before we learn one final topic for the fundamental theorem of calculus in the next video.